fantastic. Cold? Then come up here and move your arms around a bit. It's great. Let me start off by explaining something, right? I love Ruby. I've been doing Ruby since 1998. I have revved the Pickaxe book 4 times. And in fact, the latest revision went into print, well, it came off the presses on Friday last week, a week ago. And there's actually 4 copies to be won lying around somewhere. Okay, so I have a commitment to Ruby. Don't get me wrong, right? So I'm not here to say all you Ruby programmers are, shouldn't be here. It's crap, right? That's not the case. However, I also think that we owe it to ourselves, all of us, to keep an eye on what's going on. Because if we don't, as Sandy and I were discussing over lunch, if you don't keep an eye on what's going on, then eventually you're going to be out of date. How many people here used to go to the No Fluff, Just Stuff conference things? A few, not many. I'm actually kind of proud of the fact that I've actually been banned from speaking at those because I used to go to a set of Java conferences and talk about Ruby. And they said, oh, you can't do that anymore. Go talk about Java. And I said, no, I'm not going to talk about Java. I didn't do it anymore. So here I am at a Ruby conference. I am going to talk about Elixir. So why do I want to talk about Elixir? Elixir, to me, is kind of like the gateway from what I used to do to what I will be doing. And I've been looking for this for 10 years, and I finally found it. So the reality, I think, is that the future is functional and the future is concurrent. Those 2 technologies combined are pretty much the only way we can continue to develop in terms of like carrying on and get things better in software. We're kind of running into all sorts of obstacles. I'm sure you've all heard of, oh, that's not going to work. All right, don't play. You all heard of Moore's Law? For the longest time, I couldn't work out what he had to do with it, but, something like, every year you get twice as ugly or something, I don't know. But does he or does he not look like, this is Gordon Moore, right? He looks to me like the Wendy's Dave Thomas guy, don't you think? But anyway, he's cheery. The reason he's cheery is he's worth $4 billion, but he's cheery. And he came up with infamous Moore's Law. Now, Moore's Law is not actually what most people say it is. Moore's Law says that the most cost-effective density for putting transistors onto a silicon chip doubles every 2 years. Yeah? It's nothing to do with performance or anything else. It just says that Moore's Law said, I can pack twice as many transistors onto a chip and hit the most optimal point for cost effectiveness. And it is pretty well borne out. I was trying to remember when I copied the slide what the first microprocessor I used was. And it was I've definitely used 8008s. And I've used the 6502, which is the last one down the bottom there. So both of them down there have maybe 3,000 transistors on them. Right? The axis on the y-axis here is exponential, just as it was on Sandy's graph on books. So nowadays, my laptop has a Core i7 in it. So it's up there. Unbelievably, last night when I actually got these numbers, I couldn't believe it. My laptop has roughly 1 billion transistors in its processor. 1 billion transistors. And some guys actually measured the size of the processor chip, because Intel don't actually release the specs, and worked out that it's 121 square millimeters. Right? Which means that I have 8.25 million transistors per square millimeter in my processor. That's almost unimaginable. If you want to know how big a square millimeter is, well, I finally found a use for this guy. Because if you take the cross-section of a typical paperclip, it is about a square millimeter. So 8.25 million transistors in that little space there. But what that really means in practice is that you can't use, a billion transistors like you would use 10,000. If you have 10,000 transistors, you basically have them all sitting there saying, here's the addition, now go do this, now go do that. When you've got that many, then you cannot coordinate them and have them all working on the same problem at the same time in any kind of meaningful way, right? If nothing else, the speed of light gets in your way. So as a result, we're moving more and more towards multi-core and then hyper-threading inside the cores to give us parallelism in our processes. You've all heard this, right? And we've all kind of like hoped the problem will go away because this doesn't really affect us right now. We can sort of get away with writing our Rails code on our servers and we'll run end processes and it kind of works. Except it kind of doesn't. You all know the issues that we face when we try and run that way. So for those reasons, I think that we're looking at a sea change now. In order to continue to exploit this growing curve that's Moore's law, we are going to have to find new ways of writing software. And I believe that functional programming is one of those new ways. So Elixir, I think, is functional, concurrent, pragmatic, and fun. Let's spend a bit of time looking at the functional aspects. Now, initially I had 100 slides or something. I thought, screw that, let me just code instead. So I'm just try and code some stuff up. You'll get to see how bad a typist I am. And between us, we may learn something. So first thing I'm going to do is I'm actually going to go into the shell. And Elixir has a shell, just like IRB, but it's called IEX. Actually, I say it's like IRB. It's nothing like IRB. Let me just do something quickly here. Okay. So first of all, right now, I am orchestrating roughly 25 independent processes in my Elixir shell here. So the compiler is running in a separate process. The Elixir command line, the IEX command line is running in a separate shell, a separate process. And they're all communicating back and forth, which is kind of cool, and it's totally transparent. Just like with IRB, I can do things like type an expression, and it works. I can assign to a variable, right? So now A has the value 1. Except I'm not assigning to a variable because this is a functional programming language, right? All I'm doing when I say A equals 1 is asserting that A and 1 both have the same value. So because of that, I can also say 1 equals A. And it says, yep, no problem at all. Now what happens if I was to say 2 equals A? Well, that now gives me something called a no match error. And the reason for that is that Elixir will only bind new values to variables if they're on the left-hand side of an equal sign. So here, A already has the value 1, so Elixir says, I'm sorry, but whatever is over here has to be a 1 as well. Yeah? Now, I talked about pattern matching. That is an absolutely critical thing in any functional programming language. So let's have a quick look at pattern matching. We've already seen A equals 1. Well, here we have a pattern which is some variable and a scalar, and that's going to make the variable have the same value as the scalar. I could use an Elixir list instead. Okay, so now my variable A has been associated with that list 1, 2, 3. But pattern matching goes pretty deep, so I could actually say DEF equals A. And what this is going to do is say, okay, on both sides, I'm expecting to see a list of 3 elements. Well, it just so happens that A is a list of 3 elements. So this is going to match, and it's going to assign 1 to D, 2 to E, and 3 to F. Yeah? All right. We can take it a bit further than that. I can, for example, take a list like A and split it into its head and its tail. So I could say head followed by tail in a list equals A. And if I do that, then the head is 1, the first element, and the tail is the rest of the list. Yeah? So pattern matching allows me to construct and deconstruct my data. And as you'll see a bit later on, it also allows me to write really large programs without any conditional logic. Typically also without any loops. All I'm doing is declaring stuff in my code. So let's start off and actually write some Elixir code like outside this thing. Let's go into an editor here. So I'm just going to use Sublime. And just write a really quick bit of Elixir. Let's do def module. Let's call it sequence, because eventually it will be. Oops. All right. So all Elixir code goes into a module. Sorry, that's not quite true. When you want to compile Elixir code, you have to put it into a module. And the reason for that is that Elixir runs on the Erlang virtual machine, and that's how the Erlang virtual machine manages its code. You may have heard that Erlang lets you do hot swapping of code. Well, I can hot swap Elixir code as well. So in a running application, I can replace it. I replace things at the module level. So that's why I have to put my code in a module. So I can write a method, let's say hello, and we'll just say, all right, and then down here, I can call it by saying sequence.hello. Yeah? If I run that code, wow. So if you were squinting, you wouldn't think that was Ruby, right? Very, very similar. And in fact, Elixir takes a whole bunch of things from Ruby and runs with them. For example, here, you think that is a function definition, which it kind of is. But actually, it's also a function call. Because in Elixir, def is a function call. So is def module. And this function takes 2 parameters, the name of the method and the body of the method. And it just so happens in Elixir, there's a bit of syntactic sugar that lets me write the body as do end. Underneath the covers, that actually gets translated into, oops, that. That do colon there is actually just like a Ruby hash. It's just a named parameter that I'm passing in. So for example, an if statement in Elixir, if I have an if statement like if A equals B, it's do something else, yeah? Actually, again, is just syntactic sugar, because if is also just a method. Actually, it's a macro, but effectively, it's a method. It takes 3 parameters. It takes the expression, it takes the do block, and it takes the else block. And that means that I can rewrite the entire language if I want to. Right? Everything is soft. You want to talk about metaprogramming? This is serious metaprogramming. And unlike other languages you might name, it is actually done in a very controlled style. First of all, metaprogramming in Elixir is done by manipulating the parse tree, which actually happens to be an Elixir data structure. It is done in a hygienic way, so it will not overwrite any of your local values accidentally. And it is done in a scoped way. In Elixir, every change you make to the environment, whether it's defining macros or including a module, or whatever it might be, is lexically scoped. So, for example, I can say, apply this different version of a particular operator only to the parameters of this method call, which can come in very, very useful. However, that's not why we're here. So let's have a look at something slightly different. Let's have a look at lists. So what I want to be able to do is to say something like io.puts sequence, dot length of some list. Yeah? So how am I going to go about doing that? Well, obviously there are built-in ways of doing this, but let's do it the hard way. So I need to define a method called length that's going to give me the length of a list. In a functional programming language, I'm going to use pattern matching to do most of the work for me. So I'm going to say the length of an empty list, okay, I'm pattern matching here, an empty list. And what's the length of an empty list? 0. So that's taken care of one case. The other case is a non-empty list. So let's have a look at the list which has a head or a tail, and tail is potentially empty. So what's the length of that? Well, we know the head contributes 1, and then the length of the tail is simply length tail. Does that make sense? Nice little recursive definition. If I run that, it blows up. But that's okay. Kernel.length conflicts with local function. Look at that. I actually have, although it's untyped, it actually does a fair amount of work to make sure that, for example, I haven't misspelt function names, that I haven't accidentally overwritten function names. So let's call that len rather than length. So, boom, 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 boom. There we go. So a couple of things here. First of all, there's my result, 5. Also notice variable head is unused. Because here, when I did the pattern match, I set head to be the head of the list, tail to be the tail of the list, but in my code, I only ever use tail. So Elixir has a convention that if I put an underscore in front of a variable name, it says, I don't plan to use this variable. So by doing that, my warning goes away. I could, in fact, just say underscore here, and again, that just works, but I personally prefer to leave the variable name there because it documents what I'm doing. So that's a typical recursive definition. You don't find yourself doing those too often. Okay, but one of the things that I like about this, from an aesthetic point of view, is that my definitions here are pretty much the specification of what I want to write. So the length of an empty list is 0. That's someone could tell you that. All right, the length of any other list is 1 plus the length of the rest of the list. Okay, it's a specification. Let me show you another specification. This one is like, it's almost kind of like you'll groan when you see it, right? But it's actually useful for my purposes. Fibonacci numbers, right? 1, 1, 2, 3, 5, 8, whatever. Each number is the sum of the previous 2 numbers. If you go to a math book or to Wikipedia or whatever else, they will tell you the definition of the function of Fibonacci is that the Fibonacci of 0 is 1. The Fibonacci of 1, is also 1. And then the Fibonacci of some number n is the Fibonacci of n minus 1, plus the Fibonacci of n minus 2. That is the mathematical definition of Fibonacci. Yeah? But if we want to convert that into running Elixir code, all I have to do is say, right? And now I have code. So now if I was to say sequence.fib20, there it is. Is that cool? Yeah? Now, at this point, you're probably saying, but Dave, that's all very well, but how many times a day do you actually calculate the Fibonacci series? Right? And, okay, no more than 5 or 6, I have to tell you. But that's okay, because the reality is that this form of expressing code I do all the time. In fact, when I'm writing Ruby code, I'll sit there and I'll typically work out the various conditions, and I'll write them down, not as tidily as this, but I'll write, 0 is 1, or I'll write empty request means I send back a 4 or whatever. All those kind of things I would write down. I do the same when I'm writing Elixir, but it just turns out, coincidentally, I'm writing code. Right? It's really cool. So let's look at a few more things in here. First of all, let's define a map function. Now, it's the same as the Ruby map function in that I want to take a collection and apply a function to each element in that collection and return the resulting set of values. So I'm going to start off, actually let's start off with a use, because that's actually always a good way of doing things. So in this case, I will do io.puts sequence.map. Okay, so I'm going to map, in this case, a list. So let's go 4, 5, 6, 7. and I'm going to map it through my Fibonacci function. All right? So my Fibonacci sequence is going to be, oh, actually, I'll do it this way. Okay, so I wanted to say sequence.fib of some number n, or n each successive element. So how do I do that? Well, the long-winded way is to say I'm going to write an anonymous function, that's just like a lambda in Ruby, that takes a parameter n, and its body is go calculate the sequence.fib of n. Yeah? So my map function takes a collection, and it takes a function. So let's start off with that. So the map function takes a collection, and it takes a function. So what are my special cases here? Well, I think it's the same as the counting one, the length one we did, and that is if I want to map over an empty collection, then what's going to come back is also an empty collection. Yeah, that's all I need to do. So now I'm dealing with the case of mapping over a non-empty collection. So we're going to do that head-tail thing again. And we get the function. So now what are we going to do here? Well, I have to apply the function to the head of the list, because that's part of what I have to do. And then I have to generate the rest of the list, which has been mapped. So I can express that by saying, okay, fun.head. So now that's calling the function on the head. And then I'm going to build the rest of the list by mapping on the tail. And that map function is the same map function here. So what's going to happen? Let me shrink the font. If I shrink the font down, can you still see at the back? Is that okay? Okay, thank you. All right, so what's going to happen here is each time around this recursion, it's going to take one extra element off the list. It's going to convert that by running it through the function and build a new list where that element's there. Then at the very end, I'm going to run out of list. So tail will be empty, so then it comes to this clause, and it's going to terminate the recursion. So now in theory, if I run this code, oh, okay, let me change this to be an inspect. All right, I've just fallen foul of some Erlang disgustingness. Okay, but anyway, so there is me mapping my list. Yeah? That's not bad, is it? It's really quite straightforward. It's very understandable code. It is recursive. But so what? So here I've written a map function and a Fibonacci function, and in both cases I have no explicit loops, I have no explicit conditional logic, which is absolutely fantastic. Okay. So you say to me, but Dave, you're doing testing by inspection. Can we do better than that? You bet we can. So let's do something like class test it. No, not class. Oh, dear, dear. How, that's the problem. You switch back and forth between the two, and you are totally lost. It's horrible. All right, so there's my test module. I need to use XUnit, which is a testing framework. And in fact, I actually have to start the testing framework, because remember I talked about lots of processes? It runs in its own separate process. So I'm going to run that in its own process. So now I can write some tests. Test. Basic fib function works. Do. All right. So now assert sequence.fib10 equals 10946 and test basic map works. Do. So now I'm just going to cut the paste here, so I have so 5, 8, 13. Oops, I made a typo. Bad me. Okay, folks. So that's a basic unit test written using the XUnit framework. So let's see what happens when I run that. Ding-a-ding. function test2 undefined. I'm sorry, where? To get the fun thing done, yeah. But I think that's not the error I'm actually seeing here. I'm seeing a problem that test2 is undefined, which means that this test method here, which probably means I've forgotten something. Give me a quick second. I hate cheat sheet just to make sure I don't do this. Oh, I'm sorry. It's not use xunit. It's use xunit.case. That's why. Oh, there you go. That worked a whole lot better. Cannot invoke remote function sequence.fib1. Because it is. Is that what it is? Oh, sorry. It'll be 89 in that case, isn't it? All right. I'm having a really bad time here. Inside match. What's wrong with that? What on earth is wrong with that? It is not the most efficient way of doing it, I have to tell you. Oh. Okay, here we go. Here we go. Thank you. Thank you. All right. So, my test failed. Notice the error. Expected 5.8.13.21, but got 5.8.13.22. In most other testing frameworks, I would have to say assert equals that comma result, right? Remember I said that metaprogramming is wonderful in Elixir? Here, my test function actually intercepts calls to equals equals inside that block. It runs the original equals equals, but it still has access to the two operands as a code fragment. So it can take that code fragment, convert it back into text, and then use it here to show me the two values. That is pretty damn cool. Just think of the cool stuff you could do with that. All right. So let's push the boat out. I talked about it being a parallel or a concurrent language. So let's come back to our map sequence here, and let's see if we can make this parallel. And I have 5 minutes. Is that right? Somebody? God help me. All right. So I'm going to write a parallel version of map. So let's call it pmap. Right? It's going to take a collection and a function. Yeah? And what it's going to do is, this is where I'm going to show you how I think about functional programming. It's going to take the collection. It's going to run each of the elements of this collection in a separate subprocess. So we're going to call it spawn children. Let's call that fun rather than a function, just to save myself a little bit here. And then after we've done that, we're going to collect the results. So what's this pipe operator here? It's actually a pipeline, just as if we were in the Unix shell and I can pipe the output of one thing to the next. Here, I'm taking my collection, I am piping it to spawn children, and then the results that come back, I'm going to pipe it to collect the results. The reason this is significant is not that it saves me a little bit of typing. The reason it's significant is it changes the way I think about programming. Because now I think about programming as mapping from A to B, and not from doing something. So here I have a collection. I'm going to map it into a set of processes. And then I'm going to map those processes into some results. So it's a transformation. It's not an explicit imperative way of coding. So how do we code those things up? Well, I know I'm running out of time, so I'm going to do this pretty quickly. So I'm going to have my spawn children function, and it's going to take a collection and a function. And it's going to take the collection and it's going to map it. So again, I'm going to transform the collection by mapping it through, is that spawn child? Yeah. A function called spawn child. So it's for spawn one independent child. Okay? And clearly I need to pass it the element from the collection and the function. So what I could do is to say something like this, elem, fun, and then wrap this in an anonymous function just as you would in Ruby. So I'd say function, so I'm going to receive an element, and I'm going to do that. But because that's such a common pattern, Elixir has a shortcut for this. I could say map it through spawn children where the first element is the first parameter passed in, and Elixir automatically is going to wrap that into an anonymous function. It's then going to say, but wait a minute, this anonymous function is nothing more than a call to a named function, so it's going to rewrite that again into a direct function call to that named function once for each element in the collection. That's pretty sweet. Right. So what does my spawn child looks like? It's going to look like something like it receives a value and it receives a function. And this is where it gets a little bit tricky, because what we're going to do is we're going to spawn ourselves and make ourselves run in a separate process. To run a separate process in Elixir, I'm going to call spawn. And there are many different ways of calling spawn. The one I'm going to choose is actually slightly verbose, but it's actually easiest to explain. I'm going to spawn a function in my current module. It's going to be called child, and I'm going to pass it 3 parameters. So the parameters I'm going to pass it are the value, I'm going to pass it the function, and I'm going to pass it myself. Self is a current process. And the reason I want to do that is that my child is going to send me a message back to say, here's the value. So now I'm going to write my child function. Do I really write all these one-line functions when I'm writing Elixir? Actually, I do. And typically I write them on the same line just because it's like easier to do that. I find this kind of decomposition, I would actually write it like this, step at a time, just decomposing it to single-line functions. It's really a powerful way to think about it. So my child method, what that's going to do is actually send the, okay, so the child method receives a value, a function, and a pointer to self, which is actually the parent of the child, yeah? So what it's going to do is send a message back to the parent. And I'm using the Elixir, arrow thing here, which means send a message. And what message am I going to send? I'm going to respond with my own process ID and the value. And the value is fun dot. So I'm calling the function on the current value. Okay? So here what I've done is come back to my original PMAP at the top there. I've done the first part. I've spawned a separate process for each value in my incoming collection. And it's now running independently somewhere. So all I need to do now is collect the results back. And to collect the results back, I'm just going to put some extra lines so you can see it. It's going to look like this. Def collect results. Now, the result of running all of this mapping is that I'm going to take a set of values and convert it into a set of processes. So my collect result is going to get passed a set of process IDs. And what I need to do is to get the results from those processes in order. So I'm going to use a receive block. That means go and receive a message. And pattern matching allows me to control what message I receive when. In this case, what I want to do is to receive the message from a particular PID. Okay? So I haven't got that yet. I'll get that in a second. And it's going to come back with a PID and a value. And the only part of that I'm interested in is the value. So my problem here is that my collect results has got a whole list of PIDs. I want the result for a particular PID. So I'm going to break that into 2 methods here. So I'm going to say PIDs, transform them by mapping them through the function collect result for PID. And again, it takes the PID as a parameter. And now I'm going to have a method called def collect results for PID. It takes a PID, and away we go.
Naming problem on line 26.
Line 26, def, oh, look at that, collect. Yes, thank you. I mean, the chances of this actually running first time are about 0, but we'll give it a go. All right. I mean, given my luck this afternoon, it's going to be like, it'll blow my machine up or something. Okay. So what I've done here is actually a fair amount of typing. I don't have to make it so big, right? But what I'm doing instead is splitting it out so I can show you my thought process. So if we run this, and it blows up, what a surprise. Function collection results does not exist. So somewhere I've used collection results.
The name on 11 doesn't match the name on 26.
Should be collect results, right? And it fails again. You see, it's very, oh, that's my test failing. All right, let's fix that up. Yay, all right. So if I change that from being map to pmap, still works. Cool. Just to make sure that we can actually see that, and I know I'm going to get bum's rush, right? Yeah. Okay, I'm just going to show you just one cool thing, and that is, if I take that file, which is called what? T. My God, I'm imaginative. Okay. Oh, that's the wrong T. Oh, there it is. If there are any Brits here, you'll know why I called the directory Blue Peter, because here's some examples I prepared earlier. All right, so now I've loaded that file into my Elixir, so I can call sequence, oh, actually I import sequence to save myself typing. Import sequence. All right, so now I can say fib 30, say, and there's a result. So if I now run fib, if I run regular map, so map, say 30, let's make it 35, 5, 36, 37, 38, 39, and 40, I'm going to map it through the Fibonacci thing. Hey, everybody's picky. All right. And it blows up. Why did it blow up? Oh, thank you. Okay, so if while it's doing this, I call up my activity monitor, you'll see that I'm running on one CPU. Yeah? And there's the results. If I change this to use pmap, now I'm running on all 4. Is that cool? All right, I could go on for days, but then he won't let me come back, so I want to come back. So,
thank you, Dave.
I'm done. Thank you.